Motion controllers are the brains of any motion control system. In feedback-based systems, they take an input command from the user, compare it with a feedback signal from the motor, and take corrective action to bring the output and input in line with each other, ideally with little or no error. A motion controller also creates the trajectories or motion profiles that the motors follow in order to meet the desired input commands. Motion controllers also use some of the basic control laws to implement motion, such as PID, for instance. Practically speaking, motion controllers come in a variety of sizes and types. In general, they fall into one of three categories: standalone, PC-based, and individual microcontrollers. Choosing the right motion controller begins with knowing the requirements for your specific application. Perhaps the most important is the complexity of the application. For instance, a fairly simple application is one that involves only a single axis of motion and where the speeds involved are relatively slow. On the other hand, a more complex application may involve multiple axes of motion with highly synchronized coordination between axes. Each of these systems requires different controller types as well as a choice of control architecture. So basic control architectures can be either centralized or distributed. This isn't a one or the other choice, but rather a spectrum of possibilities. Obviously, the top-level executive functions that decide what is done must be centralized in a single processor. But systems can and do split out lower-level functions to distributed components at various levels. The further down this split is, the greater the bandwidth and low latency that's needed. The further up the split is, the less possibility there is for tight coordination between axes. For more in-depth information on motion controllers, go to www.motioncontroltips.com and click on Basics of Motion.